Hello students, welcome to our physics class. This is current electricity part 6. In the previous class, we learned about color coding of carbon composition resistor, temperature dependence of resistance of conductor, temperature dependence of resistivity of conductor. So in this class, we are going to discuss about very important 5 mark derivation. Okay, well, let's start today's class. So, the first derivation, what is meant by equivalent resistance of a resistors? Derive an expression for equivalent resistance of two resistors connected in series. Actually, equivalent resistance means the resistance of a single resistor which produces the same effect as the combination. Equivalent resistance means the resistance of a single resistor which produces the same effect as the combination. Okay, when resistors are said to be connected in series. So here first, let us consider the two resistors, that is R1 and R2. So this is the circuit symbol of a resistor. What is the meaning of resistor? Resistor is a circuit element which offers certain opposition to the flow of current in that circuit. So R1 is the resistance of the first resistor, R2 is the resistance of the second resistor. Here both resistors are connected end to end. If the resistors are connected end to end, then the resistors are said to be in series. If they are connected in series, 2 points very important, that is current flowing through each resistor is same, the potential difference across each resistor, that is different, and the net potential difference across the series combination, the net potential difference across the series combination, that is equal to the sum of potential differences across the individual resistors. That means V is equal to V1 plus V2. So call this as equation number 1. So this statement is very important. What is the meaning of equivalent resistance? Equivalent resistance means the resistance of a single resistor. So here, let us consider the equivalent circuit. So actually here, this is the equivalent resistance. Let's consider that is RS. RS is the equivalent resistance. That means resistance of a single resistor which produces the same effect as this combination. Okay. When two resistors are said to be in series, if they are connected end to end, the resistors are connected end to end, then the resistors are said to be in series. If they are connected in series, current flowing through each resistor is same. The potential difference across each resistor is different, and the net potential difference across the series combination, that is equal to sum of potential differences across the individual resistors. So here current flowing through each resistor is same. potential difference across each resistor is different. This point is very, very important. Okay, what is the potential difference across R1 and what is the potential difference across R2? So that can be calculated by using Ohm's law. According to Ohm's law, the potential difference across the ends of the conductor is directly proportional to current flowing through the conductor. So provided physical conditions, that means temperature, pressure, strain, that should be kept constant. Remove the proportionality, we will get the proportionality constant, that is R V is equal to Ri or V is equal to IR. Now by using Ohm's law, that is V is equal to IR. So what is the potential difference across R1? Potential difference. Potential difference across R1 is V1 is equal to I into R1. Call this as equation number 2. Okay, and potential difference across R2 is V2 is equal to, actually here I is constant because current flowing through R1, current flowing through R2, same. I into R2, call this as equation number 3. Now if the two resistors are replaced by a single resistor that is having equivalent resistance or okay, equivalent resistance means resistance of a single resistor which produces the same effect as the combination. Okay, if Rs is the equivalent, Rs is the equivalent resistance, Rs is equivalent resistance, then V is equal to, what is the value? So here is also the current drawn from the positive terminal is same, that is I. Even potential difference is also same, that is V. So V, according to Ohm's law, V is equal to IR. So here potential difference across RS is how much? V is equal to I into RS, right? Now call this as equation number 4. Now substitute equations 2, 3, 4 in equation number 1. Now substitute equations 2, 3, 4. 2, 3, 4 in equation 1. Then we get I, what is the value of V? That is IRS, right? IRS is equal to V1 is I R1 plus V2 is I R2. I R2. Okay. So IRS is equal to I is taken as common is R1 plus R2. Okay. So I get cancelled and finally we will get RS is equal to R1 plus R2. So the equivalent resistance in series, that is equal to equivalent resistance in series, that is equal to the sum of individual resistances. Rs is equal to R1 plus R2. Okay, suppose if n number of resistors are connected in series, then what is the effective resistance? That is important. If n number of resistors are connected in series, n number of resistors are connected in series, then the then effective resistance that is Rs is equal to R1 plus R2 plus R3 plus so on up to Rn. So if more number of resistors are connected in series, then the effective resistance that is gradually increases. If n number of identical identical resistors n number of identical resistors are connected in series, then what is the effective resistance? So in this case the effective resistance Rs that is equal to nr. Okay, right? So if n number of identical resistors are connected in series, the effective resistance is Rs is equal to nr. For example, if five resistors, five resistors, so each one having resistance is 2 ohm, all are connected in series. What is the effective resistance? That is Rs is equal to, in this case, what is the value of n? Number of resistors 5. Okay, so each one having resistance is 2, right? 5 into 2, that is 10 ohm. That means the effective resistance increases. So suppose if 10 resistors, each one having resistance is 10 ohm, all are connected in series. What is the effective resistance? Rs is equal to 10 into n value 10, or value is 10 ohm. Is 100 ohm, right? So if more number of resistors are connected in series, effective resistance is gradually increasing. So when resistors are said to be in series, if they are connected end to end. So if the resistors are connected end to end, then the current flowing through each resistor is same. The potential difference across each resistor is different, and the net potential difference across the series combination that is equal to sum of potential differences across the individual resistors. So in the case of capacitors in series, one, two capacitors are said to be in series. The positive plate of one capacitor is connected to negative plate of another capacitor. Then capacitors are connected in series. If they are in series, the potential difference across each capacitor is different. The charge on each capacitor is same. The net potential difference across the combination is equal to sum of potential differences across individual capacitors. Is it not? So V value in case of capacitors in series, that is Q by Cs. V1 is Q by C1. V2 is Q by C2. Q by Cs is equal to Q by C1 plus Q by C2. 1 by Cs. Q is common, get cancelled. 1 by Cs is equal to 1 by C1 plus 1 by C2. So if two capacitors are connected in series, the effective capacity 1 by Cs is equal to 1 by C1 plus 1 by C2. This difference is very, very important. In case of series combination of resistors, if more number of resistors are connected in series, effective resistance increases. So in case of series combination of capacitors, if more number of capacitors are connected in series, the effective capacity gradually decreases. The reciprocal of equivalent capacitors in series, that is equal to sum of reciprocals of individual capacitances. So here the equivalent resistance in series, that is equal to sum of individual resistances. Okay, the next very important 5-mark derivation. What is meant by equivalent resistance of resistors? Derive an expression for equivalent resistance of two resistors connected in parallel. So the equivalent resistance means the resistance of a single resistor which produces the same effect as the combination. Okay, when two resistors are said to be connected in parallel. Now here let us consider two resistors R1 and R2. Both are connected between two common points. The resistors are connected between two common points, then the resistors are said to be connected in parallel. So V is the potential difference across this combination. So I is the main current, is always drawn from the positive terminal of the battery. So actually, this is the junction. Junction means that is a point at which two or more conductors are meet. So actually, at this junction, the current is divided into two parts. So actually, this is a current divider circuit. The resistors are connected in series. Voltage is divided. That is actually voltage divider circuit. But this is the current divider circuit because at this junction the current is divided into two parts. Okay, and here the potential difference across each resistor is same. In series combination of resistors, current flowing through each resistor is same. Potential difference across each resistor is different. The net potential difference across the combination is equal to the sum of potential differences across the individual resistors. That is actually the voltage divider circuit. But in parallel combinations, in parallel combination of resistors, the current is divided into two parts. This is the current divider circuit. So here current flowing through each resistor is different. The potential difference across each resistor is same. So and the main current is equal to the sum of currents flowing through individual resistors. I is equal to I1 plus I2. Okay. Again using Ohm's law, So V is equal to IR. So what amount of current flowing through current flowing through R1 is current flowing through R1 is I1 is equal to V is equal to IR, I is equal to V by R. So here V is constant, right? V divided by R1. Call this as equation number 2. And what amount of current flowing through R2? Very simple calculation, right? So the current flowing current flowing through R2 is I2 is equal to V divided by R2. So call this as equation number 3. Now if the two resistors are replaced by a single resistor, now consider equivalent circuit. This is the equivalent circuit and this is the equivalent resistance is considered that is RP. Here is also the potential difference across RP is V and current flowing to RP is I. RP is the equivalent resistance of the single resistor which produces the same effect as this combination. Okay. So if RP is the equivalent resistance, RP is equivalent resistance, then what is the value of I? I is equal to V divided by RP. Call this equation number 4. Now substitute equations 2, 3, 4 in equation number 1. Equations 2, 3, 4 in equation 1. Then we get this value of I, that is V by RT, correct? V by RT, that is equal to I1, V by R1, I2, V by R2. So V divided by RP is equal to V is taken as common, okay, and 1 divided by R1 plus 1 divided by R2. So we get cancels and finally we will get 1 divided by RP that is equal to 1 divided by R1 plus 1 divided by R2. Okay, the reciprocal of equivalent resistance in parallel. The reciprocal of equivalent resistance in parallel combination that is equal to the sum of reciprocals of individual resistance. If more number of resistors are connected in parallel, actually the effective resistance is gradually decreases. Okay, if n number of resistors, n number of resistors are connected in parallel combination, then what is the equivalent resistance? This is very important. This is 1 divided by RP, that is equal to 1 divided by R1 plus 1 by R2 plus 1 divided by R3 plus so on up to 1 divided by Rn. Suppose if n number of identical resistors are connected in parallel, if n number of identical identical resistors are connected in parallel then the equivalent resistance is 1 divided by RT. It is equal to N divided by R. 1 divided by RT is equal to N divided by R. And RP, what is the value of RP? RP is equal to R divided by N. RP that is equal to R divided by N. This formula is very important for P. RP is equal to R divided by N. Okay. For example, if 10 capacitors, 10 resistors, each one having resistance is 10 ohm, all are connected in parallel. Then what is the equivalent resistance? So that is RP is equal to, what is the value of R? That is 10 ohm. How many resistors are connected in parallel? 10. So 10, 10 cancels. So we will get 1 ohm. So if more number of resistors are connected in parallel, then effective resistance is gradually decreasing. But in the case of capacitors, so when the capacitors are said to be connected in parallel, positive plates are connected to one common point, negative plates are connected to another common point, right? So in parallel combination of capacitors, the charge on each capacitor is different, potential difference across each capacitor is same. So the net charge that is given by the sum of charges on individual capacitors. Q is CPV. So CPV is equal to C1V plus C2V. V is common, we get cancels, and finally we will get CP is equal to C1 plus C2. If the capacitors are connected in parallel, the effective capacity increases. If the resistors are connected in parallel, the effective resistance decreases. So the difference is very, very important. So when two resistors are said to be connected in parallel, if they are connected between two common points. So if the resistors are connected in parallel, the current flowing through each resistor is different, the potential difference across each resistor is same. And the main current is equal to sum of currents flowing through individual resistors. Okay, the next topic is branch current formula. So this formula is applicable only if the two resistors are connected in parallel. Okay, here let us consider the two resistors R1 and R2. Both are connected in parallel. So V be the, let us consider V be the applied potential difference across this parallel combination. So I is the main current, is drawn from positive terminal of the battery. At this junction, so what happens? Let us consider this junction as A, this junction as B. So I is divided into two parts. This is a current divider circuit. So I1 is current flowing through R1, I2 is current flowing through R2. So the main current is equal to the sum of currents flowing through individual resistors. I is equal to I1 plus I2. We call this as equation number 1. And here the potential difference across R1 that is considered, that is V1, it is exactly equal to the potential difference across R2. Is it not? Because in parallel combination, the current flowing through each resistor is different. The potential difference across each resistor, that is same. So according to Ohm's law, what is the value of V1? V1 is I1 R1, that is equal to V2, that is I2 R2. So I1 divided by I2, that is equal to R2 divided by R1. Now I1 plus I2. Add plus 1 on both sides here. So I1 plus I2 plus 1, that is equal to R2 divided by R1 plus 1. So we get I1 plus here, what is the LCM? I2. I1 plus I2. I1 plus I2 divided by I2, that is equal to R2 plus R1 divided by R1. So I1 plus I2, that is I, that is the main current, right? I divided by I2, that is equal to R1 plus R1 plus R2 divided by R1. So we want the branch current I2. So what is the meaning of branch? Branch means, actually this is electrical network. So branch means a part of electrical network lies in between two junctions. Okay, so this is a branch. This one is also branch. I1 is the branch current. I2 is also the branch current. Okay, so here I2 value, that is branch current I2 is equal to I R1 divided by R1 plus R2. So this formula, that is very important. I2 is equal to I R1 divided by R1 plus R2. Branch current, that is equal to main current into resistance in another branch divided by resistance in another branch divided by total resistance. Branch current is equal to main current into resistance of another branch divided by total. So what is the value of I1? So from equation 1, so I1 is I minus I2. So I1 is equal to I minus I2 is I R1 divided by R1 plus R2. So I1 is equal to, so what is the LCM here? LCM is R1 plus R2, right? R1 plus R2. This is I R1, I into R1 plus R2, that is I R1 plus I R2 minus I R1. So I R1 cancels. Finally, we will get I1 is equal to I R2 divided by R1 plus R2. Okay. So again here we get branch current, that is I1 is equal to, branch current is equal to main current into resistance of another branch, resistance of another branch divided by total resistance. But this formula is applicable, this rule is applicable only when two resistors are connected in parallel. This is very important for CET. The next topic is electric energy. So the total work done by the source of EMF in maintaining an electric current in a circuit for a given time, that is actually called electric energy. So what is the meaning of electric energy? Total work done by the source of EMF. What is the source of EMF? Source of EMF is a cell. Cell actually, it is a device which provides the necessary potential difference to maintain the continuous flow of current in the circuit. So electric energy means total work done by the source of EMF. Work done by the source of EMF for which purpose? To maintain the continuous flow of current. Where? In the circuit. That is the meaning of electric energy. What is the meaning of electric energy? The total work done by the source of EMF. Total work done by the source of EMF in maintaining an electric current. In a circuit for a given time. That is the meaning of electric energy. Suppose work done in driving a charge Q through a conductor. Work done in driving a charge Q through the conductor under the potential difference V volt. So then what is the value of work done? Actually, potential is the ratio of work done divided by charge. So W is equal to VQ. So this is actually electric energy. This work done is stored as electric energy. What is the meaning of electric energy? Total work done by the source of EMF. Total work done by the source of EMF in maintaining an electric current in a circuit for a given time. Okay. So W is equal to, this is work done in driving a charge Q through the conductor under the potential difference V volt. So by the definition of electric current, I is equal to Q by T, rate of flow of charge. So Q is IT, right? So W is equal to V I T. So this can also be written in the form of actually electric power. Electric power. This is actually the first very important term. The second one. Electric power. Electric power means the rate at which work is done. Rate at which work is done by a source of EMF in maintaining an electric current through a circuit, that is electric power. It is the rate of doing work, W by P. This is the mathematical expression for electric power. This is the mathematical expression for electric energy, right? So W, that can also be written in the form of P into T, right? VIT or P into T. And that can also be written in the form of V is IR, right? I square, I or into I square or T. And that can also be written in the form of I is V divided by R, V is equal to IR, I is V divided by R. So V divided by R into V is V square divided by R into T. So these are the different forms of electric energy. So electric energy, that is measured in terms of watt second. Watt second is equal to 1 joule. 1 joule is equal to 1 watt second. Okay. The commercial unit of electric energy. This is very, very important. Commercial unit. Commercial unit. Commercial unit of electric energy. Commercial unit of electric energy is kilowatt hour. So 1 kilowatt hour is actually 1 unit of electric energy. So kilowatt hour, this is not the unit of time. Kilowatt hour, watt second, that is the unit of energy. Okay, so what is the meaning of kilowatt hour? So 1 kilowatt hour is defined as the amount of electric energy consumed at the rate of 1 kilowatt per 1 hour. So 1 kilowatt hour means the amount of energy consumed at the rate of 1 kilowatt per 1 hour. 1 kilowatt means 10 power 3 watt. 1 hour is 3,600 seconds. Okay. This is 36 into 10 power 2, 10 power 3, 10 power 5. Watt second means joule. So 1 kilowatt hour value. This is very, very important for CT. 1 kilowatt hour. 1 kilowatt hour, it is equal to 36 into 10 power 5 joule. 36 into 10 power 5 joule. So what is the meaning of electric power? Electric power means the rate at which work is done by a source of EMF. Rate at which work is done by a source of EMF in maintaining an electric current through a circuit. This is a mathematical expression. So W is actually VQ divided by T. Q by T is I. T is equal to VI. T is equal to VI. This is the mathematical expression for electric power. So what is the unit of electric power? The unit of electric power is watt. Actually, SI unit unit of electric power. SI unit of electric power is watt. 1 watt is actually 1 volt into 1 ampere. 1 volt ampere. Volt ampere is the unit of electric power. Watt is the unit of electric power. And this equation can also be written in the form of V is equal to IR. So IR into I, it is I square R. And that can also be written, so I is V divided by R, V into V square, V square divided by R. Okay. And the commercial unit of electric power, the commercial unit of electric power is, commercial unit of electric power is 1 HP, 1 horsepower. 1 horsepower is 746 watt. Okay. And the next very important term, that is power dissipation in a resistor. What is the meaning of power dissipation in a resistor? So this is third very important term. That is power dissipation. That means power loss. Power dissipation in a resistor. Power dissipation in a resistor. Power dissipation in a resistor, that is equal to electrical energy spent per second in the resistor. It is very simple. Electric energy spent per second in a resistor. Just consider a resistor that is connected to battery through a plug-in. So what amount of work has to be done in driving a charge Q through the resistor? That is W is equal to V into Q. Actually, this work done is electric energy. This energy actually that is converted into heat. So this is also equal to heat. So finally we will get H is equal to VQ, that is VIT. That can also be written in the form of I square or T, that is also equal to V square divided by R into T. This formula is also very important. So what is the meaning of power dissipation in a resistor? Power dissipation in a resistor means electrical energy spent per second, electrical energy spent per second in the resistor. It's very simple. Electrical energy spent per second in a resistor is called power loss, power dissipation in a resistor. Actually, in series combination of resistor, I is constant, that means higher resistance dissipates more power. Okay, so here what is the power loss? Power loss is in series combination, it is I square R. So in parallel combination, the power loss is T is equal to V square divided by R. This is the power loss in series combination. So in series combination, I is constant. So power loss is directly proportional to resistance. In series combination of resistors, higher resistance dissipates, more power because here I is constant. This is in series. In series combination. But in in parallel combination of resistors, V constant, the power loss is inversely proportional to resistance. So in parallel combination of resistors, the lower resistance dissipates more power. In series combination of resistors, higher resistance dissipates more power, I is constant. In parallel combination of resistors, V is constant, lower resistance dissipates more power. What is the meaning of power dissipation in a resistor? Electrical energy spent per second. Electric energy means, what is the meaning of electric energy? The total work done by the source of EMF in maintaining an electric current in the circuit for a given time. Electric power, rate at which work is done by a source of EMF in maintaining an electric current through a circuit. Power dissipation in a resistor means electrical energy spent per second in a resistor. These three definitions and mathematical expressions are very, very important. Okay, thank you.